Let's look at example 6. We're given that the probability of C is 0.37, the probability of D is 0.48, and the probability of C given D is 0.56. We need to first find the probability of C and D. We have two options for that. We could do the probability of C times the probability of D given C, or we could use the probability of D times the probability of C given D. We can switch the letters around, and we just make sure that we use the one that we have the information for. Since we're given the probability of C given D, let's use this one here. So we're going to use the probability of C and D is equal to the probability of D times the probability of C given D. Since we know the probability of D is 0.48, that's given to us, times the probability of C given D, which is given to us, which is 0.56. When I multiply that together, we're going to get 0.2688. Part B says, are events C and D mutually exclusive? Explain your reasoning. When two events are mutually exclusive, it means that the probability of C and D is equal to 0. They can't happen at the same time. There's no overlap. They have nothing in common. In part A, we just found that the probability of C and D is equal to 0.2688, which is not equal to 0. So C and D cannot be mutually exclusive. And here's the reason. The probability of C and D is 0.2688, which is not equal to 0. Are events C and D independent? In order for two events, C and D, to be independent, the probability of C given D is going to be the same as the probability of C, and vice versa. The probability of D given C is going to be the same as the probability of D, because the assumption shouldn't matter. Since they're independent, one is not going to affect the other. When I look up here at the given information, we're given that the probability of C given D is 0.56, and the probability of C is 0.37. Those are not equivalent. So we would say C and D are not independent. And it's because these are not equivalent. Part D, we're going to find the probability of C or D. The probability of C or D, if I use my addition formula, I've got the probability of C plus the probability of D, and then I subtract off anything that they have in common, which is the probability of C and D, and I fill in the information that we have and figure out the arithmetic. So the probability of C is 0.37. The probability of D is given to us as 0.48. We're not given the probability of C and D, but we found that answer in part A, so we know it's 0.2688. When we do the arithmetic on that, we're going to get 0.5812. Okay, last part of this example, find the probability of D given C. We have, let me show you up here, we know that the probability of C and D is equal to the probability of C times the probability of D given C. That's our multiplication formula. So I can use that to solve for the probability of D given C. I know that the probability of C and D is equal to the probability of C times the probability of D given C. We know what the probability of C and D is. We found that in part A. That is 0.2688. I can also fill in my probability for C. The probability of C is 0.37. And then this is multiplied by the probability of D giving C. This is what we're looking for. We want to figure that out, but we have an equation. We have 0.2688 is equal to 0.37 times what we're looking for. So we just need to divide both sides of the equation by 0.37. Then these cross off. And when I take 0.2688 and divide by 0.37, that's going to give me my probability for D given C. And we get 0.7265.